Okay, it's time now to improve our UI toolkit application. We're going to throw toolkit into the bin. The changes we're going to be making are not going to be earth-shattering. You're not going to get this, oh gosh, Microsoft have just written my new final maintenance program. And as I said right at the top of the day, this session is not about making sexy, good-looking software, okay? It's purely about building the different project types and linking them all together inside Visual Studio. So we're going to improve the UI by using the Dotnet API. The Dotnet API, in a nutshell, allows you to host .NET components inside your traditional Synergy applications. It's a cool way of adding functionality that you can't get in a traditional application, traditional Synergy application, be it toolkit or non-toolkit. So if you wanted progress bars or graphs or charts or fancy lists with super scrolling and selection and searching capabilities, basically anything you can do in .NET you can host and plug into a traditional Synergy application. There's some caveats, there's some things you've got to be aware of, there's some things you've got to be careful of, you've got to be mindful of some performance constraints and things like that. But if you're sort of clever with it, you can really make your programs look nice. The .NET API then allows us to essentially create instances of .NET types within our traditional Synergy. Many people have used the .NET API to improve their UIs. Before the .NET API, we provided ActiveX. Who used ActiveX? Does anybody still use ActiveX? Okay. You might want to think about using .NET instead of ActiveX, seeing as ActiveX is a technology that doesn't really exist anymore. And that's coming from a Microsoft standpoint, not from us. We still support it. I think ActiveX really dropped with VB6. And VB6 dropped when VB.NET came out, which was 18, 19 years ago. Yeah, it is, yes, Stephen, it is getting, well, it's not harder, it's just getting impossible to recompile it. So yeah, what you need is PSG to come and rewrite your ActiveX controls for you to .NET API capabilities. Simple as that. Make it happen. Essentially, they're very similar. If you have a nice fancy, I think we showed things like tree controls and all that kind of stuff. You can use those sort of controls that are in .NET today, and you can create great user interfaces. And it's not just user interfaces, it's anything that you want to use in the background you can still use the .NET API for. But predominantly people use it for cool interfaces. You can embed controls from things like the likes of Infragistics or DevExpress or the Telerik controls. And there's a whole host of stuff out there. You could even write your own controls. The .NET API allows you to host these components directly within your traditional Synergy. We're not talking about taking the code and building it into .NET and all that kind of stuff and rewriting the world here. There are basically two ways to use the .NET API. The first is to use the core API class. For example, .NET Assembly constructor allows you to load a .NET Assembly from your computer that's installed on your computer and have a reference to it. Once you've referenced that loaded assembly, you can then create references to stuff inside that assembly. So classes that are inside that assembly, you can then create instances of. And you create those using the .NET object. Once you have a .NET object, you can create an instance of that method, that class, and then you can execute methods on that class, or on that object as it would then be, or reference properties, okay? Just as you would if you were in a true .NET language. Just as you would if it was a piece of Synergy object code. Now this stuff works, the .NET Assembly, .NET Object and .NET Object Call, etc. But your code becomes very verbose and it's certainly not clean and it's certainly not OO-like. And it's certainly not what we recommend. The capabilities are in there, the language supports it, it's all documented, but it's not what we recommend. The alternative is to use a tool called GenNet 4.0. It used to be called GenNet, and then we added the 4.0 on. I think it had a birthday, a special birthday, so we started calling it GenNet 4.0. In a nutshell, this tool basically takes the list of assemblies that you give it, the .NET assemblies, and cleverly goes over those assemblies and works out how to call them using the .NET Assembly, .NET Object Call routines, but then wraps it up in an OO class form. So in your traditional Synergy code, you're now using classes and creating instances of classes that are under the hood going through the .NET API to make calls into your .NET classes and types. The code is an awful lot cleaner, it's an awful lot easier to read, and it is OO. So it looks a lot nicer and it's obviously modern. You create instances of types, and you can access methods on those types and properties and all that kind of good stuff. And you can really do bidirectional communication between your traditional Synergy and the fancy window that you've put up. Okay? You can call into it and give it data, and it can raise events and call into your traditional Synergy. So it's bidirectional, and it's rather quite cool. So GenNet 4.0 is a command line tool. There's no sort of click off the menu column in Visual Studio. And we use that to generate the .NET Assembly wrapper code, is how we talk about it. To run it, you need a Synergy environment, so you can run it from a command line that you open through Visual Studio, for example. And there's no direct logical to it, like a DBL-dir, something like that. It's found in the bin folder, which is under the DBL-dir folder. The tool can log things as it's doing stuff with the -log option. And basically you give it, as I say, a list of the assemblies that you want to create code for. Now, given the size of the .NET framework, which is huge, it is possible, if you have the time and the disk space and the inclination, to create Synergy wrappers for the entire framework and code that into your program. You wouldn't want to, because it would be humongously huge, and you wouldn't get much benefit of it. It would take an eon to load, and it just really wouldn't work. So you basically say, these are the specific assemblies I want. So if you've got something that's inside an Infogristics assembly, you can specify the Infogristics assembly. If you write your own assemblies, which is the sort of preferred route, so you can go into Visual Studio, you can create something in Synergy.net that's a nice WPF window, for example. You can drop an Infogristics grid, you can drop a few buttons on, you can drop a chart on, and call that my new cool UI, okay? And then use that assembly, and it will know about the other assemblies. So you don't generate the code for all the Infogristics stuff just for your custom assembly, and then you load that inside your program, but you will then see your Infogristics grids and your XYZ charts and all this pie charts and all this kind of good stuff. If you are using assemblies that are installed in the GAC, the Global Assembly Cache, then you simply specify the assembly name. If it's not, then you specify the location. Now, if you're using the location, as per the one on the slide, for a custom assembly, for example, that's not installed in the GAC, use a Synergy logical, just as you would with any other thing in Synergy that you're referencing or linking to. And as long as that logical, in this example on Vinyl XE, exists at runtime, the .NET wrapping code will know exactly where to find that assembly. Okay, so you don't need to install it in the GAC and all that kind of good stuff. And it works a bit like the way you reference an ELB. There's quite a few other options available with .NET API and the GenNet stuff, but that's for a .NET API session and not for this workshop. We're just trying to work out how to build this code, not what the code does or why it does it. Code generation creates a number of files. The first file is an include file. And in this example, it is onvinylnet.inc. This include file provides a list of the required imports that using this assembly needs, okay? And it's what's going to be needed to reference the types inside of the assemblies that you're wrapping. Secondly, there's the main or the base DBL source file. In our instance, it's called onvinylnet.dbl, and that simply contains references to the numbered source files. Underneath that, you'll see an onvinyl1.dbl. Now, we've got quite a small assembly that we're going to load into our program and use, and it's a custom assembly that we've written. This one is just a custom-made, out-of-the-box Visual Studio WPF example, just Microsoft controls. Depending on the number of controls and the size of your assemblies, the amount of code that's generated, there's only so many lines you can fit in a piece of source file with Synergy, and I know some of you in this room have potentially hit a little issue where you've written so many lines of code that your code file is too big. So what GenNet does, it understands and recognizes that that's a potential issue, so it splits it down across numbered files. So you get file number 1, 2, 3, 4, 5. Depending on how many assemblies you're trying to wrap, that will indicate the number of files that it will contain. You don't really want to go near these files. Don't try and look at them. You can look at them, you can edit them, they're just source files, but they're meaningless unless you really want to understand what the .NET API is doing, because it's just wrapping things up for you to make a nice developer experience using the wrapped code. So you could get a number of those 4 source files. In our instance, we've got onvinylnet1.dbl. Now, as we did with the Windows script library, we're going to use build events to run the code generation process, because we don't want to have to drop down to a command line to generate using GenNet 40 and then include files and all that kind of stuff. Now, generally, when you reference include files, like we've got, Visual Studio will know about them, and it will define the build type for the type of extension they've got. So for an include file, it will be content, as in if it changes it'll force a build, but that content file isn't actually built into the resulting target. If it's a source file, so it's got a DBL extension, then it will be compiled. Now if you remember from our previous slide, we had 2 source files. We had onvinylnet.dbl and onvinylnet1.dbl. They both actually do a similar thing, so we don't want to build both of them. We only want to build one of them. Okay? We actually want to build the numbered source file and not the non-numbered source file. And if you look, when you do the exercise, you'll be able to edit the numbered and non-numbered ones. The numbered one will be all the code, all the logic that's been code generated. And the non-numbered one will .include the numbered one. Okay? And that's all it does. And the reason we compile the coded one, not the .include one, i.e. the numbered one, is it makes IntelliSense easier and better, because IntelliSense doesn't work as well when you're .including source files within source files. Okay? So that's the reason why we compile the numbered one and not the base one. When you do the exercise, you'll see what we mean about which one's which, basically. So when we do the exercise, you will need to change those. So you will need to see the properties list, and you will need to change the numbered one should be compile, and the non-numbered one should be a content. Otherwise, you'll get duplicate compiler errors. So now we're getting close to having the project which will generate our .NET wrappers and build them into an executable library, which is our target. And then we can link that into our mainline program. We'll do a couple of other changes, and the same toolkit maintenance program will not display a toolkit window or a toolkit list followed by a toolkit input window. It will display this WPF control. Ooh, I hear you say. Now, there's an awful lot of code. I've mentioned this a couple of times. An awful lot of code generated by GenNet 40. And it's actually too much code for our compiler to really handle, especially if you build it in debug mode. And it's not generated in a really prototypable way either, okay? So it's not really sort of good code. So don't go looking at it as a, oh, I'll look at this as an example of how to do some really good coding. It's not. So the first requirement is going to be reduce the level of prototyping. So you'll see at the top, we're going to relax strong prototyping. Not something you should be doing, and certainly not in your application, ELBs and all that kind of stuff, because strong prototyping does protect you against passing invalid data to invalid arguments and all that kind of stuff. But for the .NET stuff, the .NET API stuff, we have to do it, otherwise the compiler just will not compile the code. So you will, on this project and this project only, have to specify that you want to relax strong prototyping, and the only relaxation you need to do, other than asleep in the afternoon, is the .NET interop. Okay? So the colon interop is the only checkbox you should have there. Now remember, this is an executable library, and because of that we need to tell it where to create. So we need to tell it the target. Again, you're going to use the logical on vinyl.exe colon. Remember to have the colon. And it's exactly the same as we did with the ELB project this morning. So as well as building the ELB, it tells it where you will find it as well. So we might as well use, as I say, the same on vinyl.exe. And finally, we need to set the build mode to optimized. Even though we're building in debug, x64 debug, we need to specify that it's an optimized build. Because, again, the vast amount of code in these generated classes creates too many symbols from a debugger point of view when we compile it in debug. There's too many symbols created. So you're never going to step through this code. You're never going to need to understand what it does. So always build it optimized, even though we're in debug mode inside the Visual Studio environment. The code we've provided you already has been coded to enable both standard UI toolkit processing and the .NET API processing. So you don't have to rewrite the code that you've been given. Because because obviously that code wants to populate a toolkit list and populate a toolkit input window. We need to enable that code, and the way we've coded it is we've used defines, and there's a define in the code, UI WPF. If that's defined, then you want to display your new fancy WPF controls. If that's not defined, you're going to stick with toolkit. Okay? So we need to be able to tell the compiler where to define this. And there's a setting on the compile tab within Visual Studio where we can set compile time defines. Okay? You do have to check the I would like to set some compile time defines, and then you have to tell it what the compile time defined is. So UI WPF equals 1. In our code, we're just checking if it's defined. So if you wanted to set that value to 2, it would still work. 3 would even work. Not sure about 4 though. Now when we build the solution, the build system will define the project and compiler defines, and your .NET code will be built instead of the toolkit code. Running the new user interface, we need to be able to tell the program at runtime, do you know what? Don't open window libraries and all that kind of stuff, because we're not doing toolkit coding, we're doing .NET API coding. We've got a fancy WPF control now. So the final step is going to be able to pass a command line to your program. Many people you may be passing command lines or have the ability to pass and process command lines in your programs back at the ranch. So we have that ability on the debug tab inside Visual Studio. For the toolkit maintenance project, we can set the command line arguments. We're just going to set WPF. If that value is set on the command line, then it goes through a different logic stream and goes to the .NET stuff instead of the toolkit. And basically, it should allow you to be able to do different things at different times. Once you specify it in there, obviously inside your Synergy program, you can use xcall cmdln. We don't need the xcall anymore, so cmdln, to get at the command line, to interrogate it, see if it's got the value WPF on, and if it has, do the .NET route. If it hasn't, do the toolkit route. So now it's your turn again. We're going to give you the code to the WPF control, but we're going to give you the code, not a library with it in. So you're going to create a WPF project, and once you've downloaded the code, you can add that into the project, build it, and it'll be a Synergy.NET project. So we've gone from repository to window library to object library to executable library to mainline programs. All those are traditional Synergy, and now we're branching into the world of .NET.